In this video, we will talk about distance and displacement and how these two terms differ from each other. Many things around us move. Some move fast like cheetah and some move so slow like turtle and sloth. Before we continue this video, let's have a short intro first. We find motion as simple to explain but not in science because it entails careful use of some definitions. So now, what is motion? Motion is defined as a change in position for a time interval. The terms speed, velocity, and acceleration are used to describe motion. So, how can we know that the object changed its position? We need to know its reference point. Reference point is the starting point or the origin for measuring motion. It answers the questions how far the object traveled and its direction. In an example below, our reference point is the house, which is the initial position, by which the dog travels going to another house, which is his final position. The same with the ambulance, its starting point is the airport, going to the hospital, its final position. There are two ways to find out how far the object traveled. First, by measuring the total length of the path traveled by the object, called as the distance. Second, by measuring the distance between the initial and final position, called as the displacement. Now, let's try to solve problems relating to distance and displacement. Let's start with distance. A dog travels 70 meters east, 20 meters south, and 70 meters west. To solve for its distance, we will just count the total length traveled by the object with a formula of total distance is equal to d1 plus d2 plus d3 and so on and so forth. From the starting point, the dog travels 70 meters east plus 20 meters south and another 70 meters going to west. The total distance traveled by the dog is equal to 160 meters. In summary, distance is defined as the total length of the entire path that the object or a person traveled in moving from one place to another, and its value is always positive. It is an example of scalar quantity, specified by a magnitude only, single number indicating the size, magnitude, or dimension. In our example, 140 meters, which is the magnitude for distance, 140 is the number, and meter is the unit. Let's have another problem in solving distance. Now, I give you 10 seconds to answer this problem. Also, you can pause this video if you need more time to do it. John travels 100 meters north, 300 meters east, 100 meters north, 100 meters east to be able to reach the church. So now, let's try to solve its distance. We have the formula for distance, d1 plus d2 plus d3, and so on and so forth. In our problem, we have the following given. Total distance is equal to 100 meters plus 300 meters plus 100 meters. So we're just going to add all those terms. So we have a total distance of John, which is 600 meters from his house going to church. Now let's try to solve for the displacement traversed by the dog and John. But before we that, let's define first the word displacement. Displacement is defined as the shortest distance between the objects or the person, initial position and final position, no matter what path it took to get to that destination. It is an example of vector quantity, specified by magnitude and direction. For example, 30 meters south. 30 meters
is the magnitude, and south is the direction. To find the displacement of the object, we just need to identify first the initial position and its final position. Displacement traveled by the dog is 20 meters south. We can solve it by using the formula displacement is equal to final position minus initial position. Since the dog traveled in a rectangular path, we know that its two sides has equal measurement. We know it already that it is equal to 20 meters south. To solve for its displacement, we will just subtract the final position and the initial position. Its final position is 20 meters going to south minus its initial position, which is 0 meter because it is at rest. So its displacement is equal to 20 meters going to south. Now, let's try to solve another problem relating to displacement. John travels 100 meters north, 300 meters east, 100 meters north, and another 100 meters going to east. I've noticed that this problem is a bit different from before. It forms a right triangle. The displacement to solve is the hypotenuse, and the both leg is the x and y axis. The Pythagorean theorem tells us that in every right triangle is a squared plus b squared is equal to c, or c is equal to the square root of a squared plus b squared.
Having all the given data, we have the value for x, which is 300 meters and 100 meters. And for the value of y, we have 100 meters and 100 meters. Adding these quantities, we have c is equal to the square root of 400 meter and its squared plus 200 meter and its squared. Getting the squared of x and y and adding them together, we have the value of 200,000 meters squared. Getting its square root, we have the value of 447.21 meters north of east, which is the value of our hypotenuse or our displacement. Now, let's compare again distance and displacement by observing the following pictures. So based on the pictures, what do you think is the difference between the two quantities? Yes, correct. You're right. So distance is the total path traveled by the object, while displacement is the shortest distance between its initial and final position. Second question to be answered by comparing distance and displacement is, can displacement be equal to distance? In our example, if John walks from his house to church at a distance of 300 meters, and its displacement is also equal to 300 meters going to S. So the answer is yes. If it travels in a horizontal motion, either going to east or going to west. Next scenario or next question is, what if John go back to his house? What will be its total distance and what will be its total displacement or its displacement? The total distance of John will be double, while its displacement will become 0 since its initial and final position is the same. Now is your chance to solve problems regarding to distance and displacement. The problem is, Israel wants to visit his older brother from his house going to his brother's school. What will be its distance and displacement? If he travels 120 meters going to east, 250 meters to north, and another 120 meters to east to reach his brother. So we have this presentation. So now, kindly write your answer in the comment section below. What will be Israel's distance and displacement?